My name is Aditya Munagapati, and today I will be explaining our project, the interactive blooming flower, that our group, the senior designers, worked on for this course. Our team consists of 5 EC students and 1 ME student. Together, our varied skill sets made for a well-balanced and strong team. Our sponsor for the project is the Electronic ARTrium, and they have asked us to design an entertaining and captivating interactive blooming flower exhibit to be part of the display at the First Center from November 1st to the 14th. Most importantly, the sponsor wants the flower to be realistic and bloom in response to relative hand height of a visitor to the exhibit as shown in the image on the right. Additionally, our team must ensure that the flower is robust and durable enough to last for the span of the entire exhibit. Some of the design concept ideas we considered when designing a solution to the problem were first a hinged pushrod mechanism, which would use an inner pushrod to move the petals in a blooming motion for the flower. Additionally, we thought of using flexional wire, which is a type of shape memory alloy actuator wire that contracts when heated via current. Additionally, we considered a rack and pinion that moves up and down to again create that blooming motion. And finally, we considered cable tendons, which would move the petals up and down via wires. So after going through various design ideas, our team decided to combine the pushrod and flexional idea to create a brass mechanical structure combined with flexional that provides both a realistic and robust blooming effect. So our design is split into 3 parts, which is the stem, the petal mount, and the concealment features. So the stem would consist of 2 hollow brass rods, an inner and an outer rod, and the inner rod would be pushed up and down via a linear actuator. The second part of our design is the petal mount. This would hold the petals of the flower, um, and these would be controlled via that inner push rod and they would push these petals up and down. Lastly, we have the concealment features, which would hide all the inner brass mechanisms and structures to create that realistic effect and make sure that the flower simply looks like a normal flower. Moving on to the mechanical design for our project, the final mechanical design is showcased by the 4 images on the right. As we can see, the 3D printed petal support structure is painted green for aesthetics. There are 6 watermill cut steel linkages, which are attached to a 3D printed black center. Uh, this center and push rod system allows for the petals to be hinged from 0 to 9 degrees, providing that blooming effect that we want. Additionally, we have a small wooden box and that's sloped to blend in better with the exhibit. We have a 3D printed petal support structure for stabilizing the bottom of the flower as shown in the top right image by number 8. And lastly, we have layered petals to produce that realistic and aesthetic flower, and that helps to hide all the internal mechanisms as you can see in the bottom right image. So as mentioned earlier in the presentation, flexional is a big part of our project as in conjunction with the mechanical design, as the flexional provides that final realistic effect we need, as having only a simply mechanical structure would create quite a robotic flower, whereas the flexional allows that natural bending like motion that real plants can achieve. So moving on to our design for the flexional, some key aspects of it are that we use orange tiger lily petals to both stand out and to hide the black flexional wire as the spots help in hiding that wire. Additionally, we have fabric glue and hot glue. Fabric glue was used to attach the flexional to the flowers as fabric glue dries clear. Additionally, hot glue is used to attach the flowers to the petal mounts. So our process was to create 6 individual petals and to create a circuit out of these petals and then attach these petals to their final petal mounts and steel linkages. So here we can see our flexional petals in action as they bend up and down in a realistic motion. So here we can see the final flexional in action. As we can see, as the flower slowly closes up, the flexional heats up and closes the flower in a realistic motion. So another important design aspect of our project was the software design. as we needed to both control the linear actuator and the flexnel in response to the hand height of a visitor. This was a requirement by our sponsor, and the code was written in C++ and was placed on an Arduino, which provided control over our entire project. So after we designed our flower and the final product was built, our flower was successfully installed on time and worked for the duration of the Electronic ARTrium exhibit in the first center from November 1st to 14th. And here are a couple of videos showing our flower in action during the exhibit. Here we can see the flower opening and closing. And here we can see the flower opening and closing in response to a hand height from a visitor. Overall, we had an extremely successful exhibit and project. We had a very cohesive and diverse team with skills that complemented each other and worked very well together to ultimately enable us to be successful. And we are excited to show off our project at Capstone Expo. Thank you.